Welcome, friends. Randall Nagy here again with a very interesting built-in report, which will bring us not only up to about 50% of where we'd like to be, but more importantly, will demonstrate how when we are even working with the built-in help system, that sometimes there can be some confusion. And in this case, we're going to cover the compile built-in, which dovetails very nicely with using exec or eval, because exec and eval are two of the modes we can use to compile Python statements as well as expressions. Another curiosity is the file name, because all I can tell about the file name is just something that's echoed back to us in an exception. And then, like the document implies, it's not going to read or write anything to the file name. It is simply a tag associated with what we're trying to compile so that we can refer to it or perhaps write to it ourselves when something odd occurs. And the compile command documentation at the time of this recording is a little confused, not only between the differences of a capital statement or lowercase statement, but also the capital expression and the lowercase expression. And my hope here is to add some clarity to what up until this point in time has been a very complicated and, to tell you the truth, very infrequently used Python capability. You might ask yourself, why the heck would I want to be using compile? And that's a good question, because the only thing that compile does is to create a class type of code, and then we can either use eval or exe so as to combine the ability to inject environments into our statements. And therein, I believe, is the power, which isn't really realized by compile alone. And one of the reasons why I believe that's the case, because compile simply returns a code potential. In other words, it doesn't run until we use either eval or exe, as we demonstrated in our previous session. So compile only returns a prospective or potential object. I call it a potentia because until we actually execute something or eval it, we won't realize our results. So whenever we create an object, here we're going to limit ourselves to either exe or eval. We'll talk about single later on, as we may expect if we evaluate an expression, simply in this case a list, as we'd expect, and as we've discussed, eval returns none. Otherwise, of course, compile would return the object that was compiled. So on a certain point of view, we're talking about a single statement with a capital S. Compile, eval, as well as single all work pretty much the same way. It's only when we get to importing modules or compiling multiple statements that we're going to run into a little bit of problem. Keep in mind, no matter what we compile, there's only two ways to realize that potentia. That way is to either use the eval or the exe built-in functions. So here's an interesting idea. Whenever we see a compilation, in this case, we're going to evaluate something, we understand that evaluate, unlike exe, returns something to us. At this point, we should also notice that by default, when we're using our global environments, eval, whenever we're evaluating, is not going to affect our global environments. In other words, it's a what-if operation saying, what happens if I would evaluate a single statement with a capital S? And of course, our global environments, as we may expect, won't be changed much. However, if we try to assign something or create a multiple statement, you can imagine that assigning things would actually change our environment. So we're going to throw an exception, and our syntax error tells us a lot, just like we saw previously, of where the problem is. In this case, actually trying to assign something rather than simply returning a result. So while eval can reach out and touch something in our environment, it's not going to modify it. And from a very loose point of view, you can think of eval as being a way to ensure that our environments are not mutating, and although it does indeed return a result, we might want to consider eval to be an immutable operation. Conversely, when we're using single or exec, we are actually going to be changing our results. And here we get into a real interesting situation, because if I were to compile something that assigns as well as increments the value of A, for example, in our environment, it doesn't really make sense to do anything besides evaluate it, because what we're going to return is the result. And the multiplication, of course, would give us A remaining as 40 after the mutable single operation occurred. Now, single and execute don't have to be mutable, but in this case, there's a little point of using an exe if the result isn't going to be returned or used. So eval is typically what I like to use whenever I'm working with either exe, single, or eval as the mode to the compiler, because it returns a result, and returning none is fine, as we see here at the bottom. Even though we threw away our result of A plus 5, both single as well as exe went out and changed our global environment so as to save the result. So whether we're using eval or execute, of course, whenever we want to evaluate as well as return something, single is the way to go and stands pretty unique, once again, assuming we're using the proper built-in function to either return or ignore our result. So the Python documentation also says that exe is the only way to evaluate a module, and unless I've done something horribly wrong, I have been able, of course, to evaluate, once again, my preferred way of working with a potentia, the importation using single or exe, and noting that the only time we're going to throw an exception or the operation won't really complete is when we're using evaluation, which of course I like to think of as being a module consisting of more than a single statement, certainly containing many expressions. So when you're selecting which compile, there are rare edge cases where we want to have different environments associated with our code, and that's when we can see how we would want to either eval, so as to compile a statement, or check what if against a immutable environment, or to exec, so as to compile an expression to make it so and apply it to a module so that we can see their effects rather than simply have them returned to us. Single, of course, expands both. We can do a module, unlike what the documentation says, as well as compile expressions and single statements, let alone see the effects and the results as we just saw. So the parameter options include, of course, our source that we'd want to have compiled into a code class. It could be either a Unicode string, a byte string, or something incredibly bizarre. Once again, the only extremely advanced Pythoners would come up against something known as the abstract syntax tree, or the AST, which, as its name implies, it gives us syntax related together into trees, which makes it very easy to parse, and even has a module for us to look at over on GitHub for more information. So while we can compile source code using the compile built-in, we can also use AST parse, which once again would accomplish the same thing, but also to take a final look through as well as to walk through the different options, much like evaluations and executes have their own global and local environments or dictionaries to pass into our code as well. There seems to be a bit of confusion over file name out there. It certainly was when I first used the parameter, because in the documentation it says it is a file from which the source came from. And I thought maybe I might even have my errors put out into the file, but both assumptions were wrong, because all the file name is the file name or tag we want to associate with the operation, whether we're logging what's going on or perhaps catching out errors. I find I can simply use an empty string, whereas most people, certainly the convention on the internet today, as admitted in documentation, uses the string in a set of delineators. But what you use is up to you, and I find myself using an empty string more often than not, certainly at the REPL mode, And the mode, of course, is pretty much as we mentioned. We have single, eval, and execute. And I find the great span between eval and execute to be single with an eval, because not only can I change my environments, but more importantly, I can see the results that I might otherwise lose, for example, when only using execute, so as to evaluate expressions. Once again, keep in mind, all three of single, eval, and execute do very well with a statement with a capital S, but eval does very poorly when we have an expression. The flags are a little odd, and we can either use a future statement or a future flag, if you would, as well as compiler options, or the options that we may pass into the command line or may have defaulted, or can specify, once again, some incredibly advanced AST options, which, once again, I don't very often use unless I'm doing a lot of security testing or syntax testing of my code base. Great for both security as well as regression testing. And unless I am debugging or testing assertions so as to provide alternative explanations as well as dog tests, the command line default of -1 or 0, 1, and 2 simply allows us to change the meta information and activate or deactivate code and options, which have a lot to do with testing our assumptions, as well, of course, as the dunder debug global flag. Well, I hope we added a little clarity to what, even to tell you the truth, at the time of this recording, the Python documentation seems to have a hard time documenting. And of course, that will change in the future because the good people over at python.org are spending more time on the documentation than they have traditionally done. And our review questions could include our new advanced questions, which includes KA 3044 on compiling, of course, where we'll be able to pick out the answer if asked if compile's built-in compile operation may either 1, use eval or exe, 2, parameters allow locals, 3, parameters allow globals, 4, requires a file name, or 5, compiles and executes code. Designed to be a tricky question, keep in mind that we're talking about compile rather than anything else. KA3046 is what I hope will sink in out in the industry at large, that in Python's language definition, a capital expression may have many capital statements, but a statement cannot have many expressions. True or false? KA3047 is also a really easy question because we're going to ask if an expression may have many statements, but a statement cannot have many statements. Once again, true or false. KA3048, Python's built-in compile, in my mind, comes down to either 1, eval exe single, 2, debug eval single, 3, compile, run, debug, 4, secure, lock, unlock, or 5, compiles and executes code. KA3049er, we have a question about Python's built-in compile. 1, returns a code class. 2, is realized using exe. 3, is realized using eval. 4, 2 of the above. Or 5, all of the above. KA3050, when we're compiling something, for example, we start off with A being assigned to the value of 4, and we're going to evaluate a compilation process where we're simply going to add 5 to what's out in our global environment. Using exe, what would we create? Either 1, A equals 9 afterwards, 2, A equals 4, 5, a syntax error, 4, 2 of the above, or 5, none of the above. AA 3051, our last advanced question on compile. Given the exact same operation where A starts off equal to 4, then we evaluate a compilation of that A plus equals 5 using eval. Would we, 1, get the results of A equaling 9, 2, A equaling 4, 3, syntax error, or 4, 2 of the above, or maybe even none of the above? Just like when we're going through our demonstrations, I sincerely hope that you are going through your own REPL mode sessions because, as I'm going to keep on saying, software development is a very lousy spectator sport. We need to be hands-on and doing things, and while I would be very surprised if anybody had compilation questions on their interview process, it certainly wouldn't hurt to be familiar with the various nuances and side effects of using either single eval or the exe modes whenever we reach out into our globals to apply our code into our local, global, or default compilation environments. Thanks for watching, and we are 50% through our coverage of Python's built-in functions, and the moment we hit a solid 200 PyQuest cards, my present plans are to update my Amazon book so as to provide some easy, printable, high-quality cards that we can use, as well as help us to master the many weird and wonderful operations in the modern Python programming world.